In 2016, an ESA-led mission, you've probably read a lot about this if you've been following Mars, the ExoMars mission. This is ESA-led with a major partnership from the Russian Space Agency, and they're a new partner in this, and we're going to provide the UHF comm system, Electra, for that mission. And one of the things at Mars that's crucially important is the comm system to be able to communicate from the Deep Space Network and the European Deep Space Network and Earth, and then from the orbit of Mars down to the surface. All of the data we're getting from the Mars Science Laboratory Curiosity comes up through orbital relays, through Odyssey and Mars Reconnaissance Orbiter. So as participants in that ESA-led mission, we will join with the science teams as well. So we're going to share in the science data. That's the ESA Trace Gas Orbiter. The Russians and the Europeans are providing the instruments, and there will also be an entry, descent, and landing experiment on that mission, and we'll provide help and engineering as best as we can for that mission. We've offered that up. The details of that are still to be negotiated. The next step for us is to start working on the memorandum of understanding and the official agreements to allow us to go forward with that, but we're going forward with that. The next big step is 2018. Again, this is an ESA-led mission. This is the ESA ExoMars mission. In the budget buckets of ESA, these ExoMars missions are not in their science portfolio. They're in their exploration portfolio. These two missions are actually part of their exploration effort, and they're going to do science because when we go explore, that's the important thing to do. But it's interesting to note that at NASA we have different buckets, and so I'm representing the science piece. But as you've heard, in the bigger context, NASA has been challenged, and it's been part of, I think, the lure of spaceflight, since before the days of Von Braun, that humans want to go to Mars. That's the great target, and we have a challenge actually from the current administration, from President Obama, to send humans around Mars in the 2030s and to land somewhere after that. He said he wants to be around to see that, and I think we should do that. We have a Mars exploration program, and they've been partners. For instance, on the Mars Science Laboratory Curiosity, there were experiments, the RAD experiment that we heard about yesterday in the press conference, the Medley instrumentation. They've been partners in our Mars exploration, and I see that growing. And so in the ESA exploration program, we're providing the science. On ExoMars rover in 2018, we're going to provide the front end instrumentation for the Mars Organic Molecular Analyzer. This is really the keystone experiment that will ride on the rover. And again, this is a participation with ESA and Roscosmos, and we're a partner by providing this instrumentation, in this case built by the Goddard Space Flight Center and partners. Okay, then the next big news, and this was really the main event at lunch today, is we're going to initiate work on a Mars 2020 science rover. This is going to be based on the same architecture as the Mars Science Laboratory. I'm very excited about this. We're going to build a science definition team to come up with the new science responsive to curiosity and the science that we've learned from Mars since the decadal survey. And we'll have to consider all of those aspects, whether we should, what kind of sample handling, what kind of drill, if we core, how we analyze the samples, and whether we cache for a future sample return. And so all of that's been queued up, very excited about. So this is now looking like quite a robust plan. And I think the fact that we were able to address this announcement to the AGU is significant. We've got lots of budget issues. We're still in a continuing resolution for fiscal year 13. There are questions of sequestration. The administration is still considering our input to the FY14 budget process. But all of these things that we've shown here fit within the President's budget request for fiscal year 13. We say that it's in guide. Maybe that's too much of an inside Washington term, but it means that within the current Mars line that the President has proposed, we can do all of these activities. And so it's a real sign that the administration, that the folks at the Office of Management and Budget, the folks at Office of Science and Technology Policy, all of those folks have approved this plan going forward. And I think it's a signal that, folks really care. The administration, the Congress, the American public care about Mars exploration. And so we're going to move forward on this pretty rapidly, put together the science definition team, Hopefully we'll have an announcement of opportunity for instruments out in the June-July timeframe next summer. And in the meantime, we'll be looking at all the components that we have from the Mars Science Laboratory. When we built MSL Curiosity, as we do for many missions that are critical missions, you buy spares. For instance, the MMRTG, the Multi-Mission Radioactive Thermal Isotope Generator, that powers the Curiosity. This is the radioactive plutonium source that generates heat, that converts to electricity, that powers the batteries that drive the rover. In fact, Curiosity is a hybrid. It has batteries and a power source, and it charges the batteries and then drives, and then at night recharges the batteries. But we have a spare, a flight spare. Well, that will become the prime for the 2020 mission. And there was an engineering test unit that we'll try and upgrade to a backup. There are probably many other spare parts. So we're going to start doing the inventory and start building the actual project plan. And it's the availability of the spare parts, but also the people and the engineering that went into building Curiosity that we still have. The team is currently working on analysis of the entry, descent, and landing data from the Curiosity landing. So this whole team of folks at contractors, at the Jet Propulsion Lab, at Goddard Space Flight Center, all around NASA, Langley Research Center, that team is still together, and we're going to then leverage that to build on the Mars 2020 rover, as well as help ESA on the 16 and 18 opportunities. That's what enables us to do this whole plan within the current budget. So this is the new Mars exploration plan. We are going to work with the Human Exploration Operations Mission Directorate and the Space Technology Group to come up with what the final configuration of experiments and things that we'll do. But I imagine, as we go forward, and in the arrow on the right, future planning is, okay, what does the rest of NASA exploration look like? What does the rest of Mars exploration look like, so that we can fill in those blanks? And hopefully over the next 6 months to a year, more of those details will emerge.